This semester, it's the very first day of class, and we have lots to do today. We're going to think about some of the things from last semester, things we need to remember for success in 302, figure out some things about the folks we have here who are going to be helping us as a teaching team. Randomly, we also have the CNS videographers here who are taking some pictures of people. They're just trying to get some action shots of learning in action. And so everyone do your best to be learning today so that it looks good on the video. Quickly, I want to think about meeting our teaching team who is here today. So if you are a graduate TA and you are here, and if you are an undergraduate peer learning assistant, could you all stand up a second so people can see you, lay eyes to you. Lots and lots of help in the class, so we will very quickly run around so that we can have everybody introduce themselves in 2 seconds. You can just tell people your name and whether you're a graduate or an undergraduate learning assistant.
I'm Lee. I'm a graduate TA. I am Emily, and I'm an undergraduate at LA. I'm Travis. I'm an undergraduate at LA.
I'm Mason, and undergraduate at LA.
I'm Sydney. I'm an undergraduate.
I'm Danny. I'm an undergraduate. I'm Bay. I'm an undergraduate.
I'm Mispa, and I'm also an undergraduate.
I'm Vincent. I'm also an undergraduate.
I'm Sean. I'm an undergraduate.
I'm Caroline, and I'm an undergraduate.
I'm Michael, and I'm an undergraduate.
All right, excellent. We also have Sophie who is here. She's going to be helping me up front as well as helping out going on. And we're missing one of our graduate TAs. Oh, there she is. Great. She's just in the nick of time.
I'm a graduate TA.
Super. All right. Oh yeah, if somehow you are strongly opposed to showing up in our video, make sure you come and let us know. But beware, the front of the room all the time is on the video cameras in the back, and that's so that if you're not here in class, that would never happen, but if you're not here in class, you would be able to watch after to check out what the video is. Thus the warnings on the door outside saying, beware, you will be videoed. Want to think about the syllabus very quickly. I'm not going to spend lots of time going over it because you can go and check it out yourself. It's on our Canvas site, so you want to be sure you get to Canvas and then look for the class. There are 3 classes on Tuesday, Thursday that will be together, mine and 2 of Dr. Sparks' sections. For simplicity's sake, we are sharing our assignments since we're doing all the same things, and so we have one site. So you'll be alternatively getting announcements from me or Dr. Sparks. Most important things on the front here will be quizzes and assignments you need to do, but today you want to make sure you be able to find the syllabus and look at the syllabus for the class. So one thing of note, we have one class email. It does say Sparks class, but that's where you want to send it as well because we have a TA who's assigned who will get you an answer to your question or forward your email to the person who needs to answer it. And so you want to be using that email. It has our content for what we're doing this semester. And then things are much the same as before. So if you took 301 elsewhere, you'll want to be sure to review the syllabus to a greater extent. Otherwise, it will be much like it was last semester. We'll be making use of 3 additional online out-of-class learning sites. One is Top Hat. That we're going to use for class discussions. We have TAs who are assigned to be looking for questions all the time, and I encourage you all to look for questions all the time so that if you have a question about a homework or a concept or something on the syllabus you're trying to get figured out, PIATS is probably the fastest way to be able to get a response. Starting right off the bat, too, we have some assignments. And I should say, we have some assignments. It's super exciting. We have a sapling homework that's coming up. We have 2 sapling homeworks, both 0 and homework 1, and those are for next Tuesday, but we have them open now. One of them, and or both of them, are these 2, 0 and 1, are both review. One is kind of a get-to-know sapling thing, and one, if you guys had actually signed up for Top Hat, I have a question for you, so you can log on to your Top Hat If somehow you've never heard of Top Hat in your life, it will be okay, because after class you will go and figure it out. If you've forgotten to your login password or whatever, you will, again, it will be okay. Today it will be credit all around, but I'm hoping to see just where people are in terms of remembering for last semester. And our question is very simple. Okay, I'm just going to look at the answers here. Don't change your answer based on what other people say. You should stick with your original answer. Whoops, I don't know what the right answer is. There we go. Oh, look at that. How nice. It's in class, but probably had less working in terms of some activities. We had one person tested out a 301, and then 4 folks who just, it's going to be a whole brand new experience. And so 4 folks, if you're a little lost after today, because the vast majority of people are plowing along in the way that we did 301, make sure that you take the chance to review the syllabus. I just want to say my office hours are normally Wednesday from 3 to 4, but this week only, they're at a different time. My office hours are going to be Wednesday 4 to 5, and they are in WC Hogg, not Welch, WC Hogg across the street, 2.222222. And this is when things are normally, so you can see any given day. Monday, want to know where to get help. Tuesday, want to know where to get help. Lots of chances. Nobody wants to study on Friday, so there's not a lot of office hours on Friday. And these will be updated, and we keep track so that you guys have a lot of chances. The other thing to keep in mind, there are reviews during the week that will go over what we've covered in class. And additionally, these same review times will be used before exams. So with that, want to think about what's going to happen in class. And in that vein, we have a little video to think about. It's this one here. We'll see if we have any sound.
I thought it was going to be an easy introductory chemistry course. I kind of ignored the rumors of that it was really a challenging course, and I thought it would be a lot like high school chemistry, which came really easy to me.
I always knew that Van Briggs class was, unique. Like I said at the beginning, you have plenty of opportunities to learn. They don't just teach one specific way. It's not just a lecture, an hour and 30 minutes, go home and learn it.
This class is definitely a lot of out of the classroom learning.
It's kind of lectures, you do demos, you do worksheets. You have the textbook, you have homeworks, you have videos.
I would say probably 80% of what I know now has been taught to myself outside the classroom, but it's because they've given me those sources. And if I didn't catch something or I missed something in class, I was able to go back to the videos and really learn from those. And the homework just sort of helps solidify the information. It is a tough course, so you're not going to learn everything just in the lecture.
I like the new strategies, like the in-class activities. Helps you be involved in the class instead of just sitting there zoned out.
Along with talking to my friend, I would constantly talk to the TAs. By this point of the year, all the TAs actually pretty much know who I am, or at least some of them, because I always ask questions and whatnot. And I think utilizing that resource in class was vital.
Signal bond, that's the head-on. That's the one that attaches them directly to each other.
Sometimes as students, we just kind of want to learn what happens.
It's really getting a real-life understanding of everything and being able to apply it to the science side of things.
All right, so with that, I just want to emphasize a couple of things. One of the goals in the class is to get you to think and to try to approach problems in a particular way and understand the world around you from this molecular perspective that we develop as chemists. The best way to do that is to practice doing that. And therefore, we're going to work on practicing doing that in class. And we'll do it in a number of different ways. There will be times where I will ask you to do things that you have not. Students here say things like, oh, all of the learning I did was outside of class. I'll secretly tell you that's how all learning works for all classes. It's from the practice that you get. And we want to set up the time in class to model how you should be approaching problems all the time. And so now is our chance with our learning assistants who are here to prod and help you answer questions, as well as to give you activities that guide you through how to think about a problem. And so today, we want to think like a chemist about a couple of liquids. So we should have an activity. Hopefully, you have a course pack. And there, you hopefully have the activity on page 11. If somehow you don't, because, you just didn't know there was going to be such a thing. We have one here, and in theory, we have copies that we're going to go get, so that those of you who don't have one, hopefully you can share with your neighbor. We're going to think about two things. Two things that seem very, very, very similar to one another. I have them here. They don't look like much. I have a bottle. Actually, I have all kinds of bottles of things that are the same. I have a bottle of acetone, and I have a bottle of isopropanol. They're two clear liquids. They have very similar chemical structures, but some of their properties are very different. And so the first part of our activity is going to bring back that idea from 301 that structure determines properties. That's why we care about structure and bonding. Very important to think about intermolecular forces and to think about properties, not just for small molecules, but in terms of interacting for all kinds of big molecules. And so we want to start out, we'll see one property for this particular comparison with liquids, which is boiling points. And so first we're going to think about structures, and then we're going to think about thermodynamics. And along the way, I'm going to ask you all some questions in terms of what the structures are. And Sophie here has the upgraded 302 only platinum stars. It's true, more valuable than gold. And if you don't like platinum, we'll just say it's, I don't know, like rhenium or something like astronomically expensive. And so we have the upgraded stars for participation, and we have after class, should you end up with a star or we don't have any candy today, we'll have, oh, we do, look at that, so prepared. We will have one of the graduate TAs up collecting your name after class. So with that, make sure we churn along, start working on what is the structure and what are the intermolecular forces, and we'll check in very shortly. If you get ahead, don't stop, just plow ahead. That's the beauty of the worksheet, is you know what the questions are that are coming up. Yeah, raise your hand if you need a copy so that the LAs are running around. Ooh, lots of people. Here we go. And as you're sitting awkwardly, quietly working on this, you might want to consult with your neighbor, who might be able to help you move along very, very much faster, so that you have some chance to have a gut check about what you're thinking and whether it makes any sense or not.
It's going to make a structure. It's going to be an odd structure.
What does it mean by
That just means it's written in the way that they're bonded together instead of it saying C2 or C3, right? You could put all the carbons and all the hydrogen all over it, and it just shows the way they're bonded.
Just to help you along on the structure, because we don't want to spend endless time on the Lewis-Dot structure, all the carbons are bonded together. Carbon, carbon, carbon. When in doubt, make a carbon chain. Carbon, carbon, carbon. Start with that. You want, there you go. You cruise along, and then the challenge is here.
I don't remember.
Got some extra ones in this one.
Okay, the structure is super important, but I don't want to spend the whole day thinking about Lewis-Dot structures. So I'm just going to give you all the structures, and then you'll be able to think about the intermolecular forces. So it's carbon, 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 OH, hydrogen, 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 hydrogen. This is the line structure for that. Or carbon, 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 double bond to the oxygen. And what's really much more important in 302 is going to be thinking about, so interpreting structures is a very important skill. So that's what you want to do with these next questions. Given the structure, what can you tell me about the intermolecular forces? For which you have to know something about the shape. Now it's gotten awkwardly quiet again.
Okay, so in a sense, the way that it's going order, it's just to give you a hint as what the probably telling you that the ozone box is huge. Because both of you notice both of these.
There you go. Excellent.
Just give me a good sense of what that is.
Yes. Okay, I can
Still one. By saying that person will help.
Like this one.
Or is that always so,
Is there a hydrogen on the oxygen?
Okay, so we can keep moving along. And again, I know this is lots of stuff coming up from last semester, or not, but it's useful to think about these things. I want to just quickly run through, in terms of molecular geometry, say, thinking about what the molecular geometry is. If we imagine this isopropanol, tell me what the geometry is around this carbon that's right in the middle. Brave soul, yes. What do you think it is? Trigonal planar. Ooh, are we sure? Does everybody agree? Disagree? I gave a bad reaction, so you disagree? Yeah, what do you think it is? Tetrahedral. It's my structure's not very good here because I had to sneak in this last little hydrogen here. It's got 1, 2, 3, 4 things around it. So 4 things around it's going to be tetrahedral around that carbon. What about this one here? What do you think it is? Yeah. Trigonal planar. There you go. That one's trigonal planar. Because it's got 1, 2, 3 things around it. And so want to think about sort of the shapes of these, but nonetheless, these molecules are kind of big, awkward, kind of funny little molecules. If we think about the intermolecular forces, what kind of intermolecular forces are there for, say, the acetone? If you had to describe the intermolecular forces in acetone, you would say they are? Yeah.
Dispersion forces and dipole.
There you go. So there's dispersion forces, also known as the London forces. And there are dipole-dipole forces because the molecule is polar. Why do you think it's polar? There you go. There's this oxygen up here. It's more electronegative than the carbon. Have a partial negative charge there, partial positive charge here. Looks like it'll have a dipole going down it. So if the charges aren't all evenly distributed everywhere, it's going to end up being polar, which is typically the case. What about are the forces in the propanol? Yeah.
Dispersion, dipole, and hydrogen.
There you go. Dispersion. Why? Everything has dispersion forces. Dipole, because it's polar, same thing. It's got that oxygen up there. It's going to create a little negative charge. And then last but not least, you said it has hydrogen bonding. Why does it have hydrogen bonding?
There's an OH
Because it has an OH group. If you've got an OH group, you've got hydrogen bonding. That will get you very far in life. You need a hydrogen, which is bonded to an oxygen or a nitrogen or a fluorine, but that's just HF. So it's really the things to remember: a nitrogen with a hydrogen on it, oxygen with a hydrogen on it. That's going to create a very strong force between that molecule and another molecule. A hydrogen on that one OH group will look for an oxygen on another OH group on a different molecule. Okay. Okay, I want you to put, as best you can, just like one little drop right in the middle. It's going to come out a lot. There you go. Okay, that's good. And now let's see if you can get one little drop in there. Oh, that's good. Oh, that's all right. We're good. Okay, so now, can anybody see the liquids at all? No. No, it's worst demo ever. Okay. Can you guys see it? Because you're going to have to report to everybody. Is there liquid in here?
Yes.
Okay. And if you had to guess, which one does it look like is evaporating faster?
The one on the left?
The one on the left seems to be. Is it there anymore?
No.
Yes, come on. Oh my goodness, it's gone. It's like you didn't put a drop in. Did you actually do it? Yeah, you did?
Yes.
You promise? You put a drop of liquid in there?
I promise.
Okay, excellent. So one of them is gone and the other one?
It's still there.
Still there. Still there. It's amazing. One of them is just evaporated and the other one is still there. And so which one evaporated?
The acetone.
The acetone. And so now for the $65,000 question, which one do you think had the stronger intermolecular forces?
The isopropanol.
The isopropanol, yeah. Molecules stick together more and they're not evaporating. Okay, so stronger intermolecular forces is going to mean higher boiling point and lower evaporation rate. Harder to pull the molecules apart from each other. So now I want to look at that from sort of a thermodynamic standpoint. So many thanks to our lovely volunteers. And let's plow ahead. We have to think back now. Now it's really churning back into your knowledge. We're going to bring back thermodynamics. Oh, I love thermodynamics. Thermodynamics, everyone should love thermodynamics. And I'll tell you the beauty of thermodynamics, and this is the beauty of this semester. We get to move from the calculate the work and calculate the heat thermodynamics into the really cool, is it positive or is it negative, and how does that tell me what happens in the world thermodynamics? And so now it's much more on just the is it positive or is it negative, is it endothermic, is it exothermic, understanding of the way the world works, and not into the can you do the integral of the heat capacity divided by the temperature, something, to figure out the entropy for temperature change. Instead, we're going to think about why would protein folding be spontaneous? Or why in the world would something evaporate or not evaporate? And we get to think about things from a conceptual standpoint. So first question is, which of these things do you think has a higher enthalpy? This is a general question. Liquids or gases, and here it's actually liquid water or gaseous water. So, see if I can actually get this question to go. Whoops, I want to do this one. Okay, so liquid water, gaseous water, they're exactly the same, it depends on the temperature. Enthalpy, which one has a higher enthalpy? Try to answer for yourself, and then once you're convinced you know what the answer is, see if you can share your answer with your neighbor, and you guys either have the same answer or you're in complete disagreement.